Quadratic transformations. Vertex form. A quadratic in the function a times x minus h squared plus k when a, h, and k are constants. The vertex is the minimum or maximum point and can be found with the values h, k. Okay, first we're going to talk about translations. That would be left, right, or up, down movement. We're going to see this, the left-right movement, whenever we look at our h value. If we see a minus h in the equation, then our graph shifts to the right h units. If we see a plus h, then our graph is shifting to the left. Likewise, if we see a plus k, our graph goes up, and if we see a minus k, our graph goes down. Don't forget the vertex is always the point h, comma, k. Graph the parent function and the transformed function. Describe the transformation and identify the vertex. Okay, to graph our parent function first, I'm going to use this first table. I'm going to write the equation in that box on the top. So f of x equals x squared is my parent function. And anytime I'm graphing, the first thing I want to do is find the vertex. Recall that's the point h, comma, k. If we look at the parent function here, just x squared, our h and k are both 0 because I don't have anything in those spots. So h is 0 and k is 0. That point we're going to put in the middle of our table. So your vertex always goes right in the middle of your table. Now we need to find some more points to plot. So in my x-axis, I'm just going to subtract 1 going up and add 1 going down from 0. So I'm just filling in these numbers on either side of 0. To get my y values for these points, I'm just going to take each of these x values and plug it into the parent function. So we've got negative 3 squared. If I plug negative 3 in for x, I'm going to get out 9. Negative 2 squared, I get 4. Negative 1 squared, we get 1. And you should notice a little bit of a pattern here. Because I put my vertex in the middle, my y values above and below my vertex are the same, 1, 4, 9, 1, 4, 9. Okay, on to our transformed function here. So go ahead and write the function in the box at the top of your table. And we need to find h and k. So in this case, our h is going to be a positive 2, and k will be positive 1. So let's stop and look at this for a minute with our h value. It was x minus 2, but I always need to change the value of, or the sign of h whenever I pull it out of the equation. So we've got a positive 2 for our h. And my vertex I went ahead and wrote in the middle of my table. To fill out the rest of my x values, I'm just going to subtract 1 over and over going up and add 1 going down. So I'm just moving by unit of 1 in my x values. To find my y values, I am plugging in each x value for x in my equation. So for negative 1, I'm going to plug that into the equation where x was, and I get out 10. Same thing with 0. I'm going to plug that into my equation, and I get out 5. And again with 1. Now, you can either plug 3, 4, 5 into the equation the same way, or following the pattern that we saw before, we know that these are just going to be 2, 5, 10. All right, moving over to our graph now. I think you can notice here that our graph doesn't have an x and a y axis, so we need to draw those in. I can move my x and y axis however I want to make sure that my points fit on my graph. In this case, all of my x and y values are 10 or less. So I can just draw my x and y axis in the middle since I've got 20 squares both directions on my grid. Okay, starting with our parent function, let's graph our vertex and the other points from our table. So there is our parent function. Then same thing for the transformed function, we are going to start with our vertex and then the other points. Okay, And the last part here, we're going to describe the transformation and identify the vertex. Well, we've already got the vertex identified. I've got a little arrow pointing to it, 2, 1. Let's talk about our transformations. Looking up at our equation, I have a -2, which means that I'm moving to the right 2. And I have a +1 for my k value, so I'm moving up 1. Now, let's check our graph here. So go back to the graph. Did our blue graph move from the origin, from the parent function, right 2 and up 1? It definitely did. So you always want to double check your graphs this way, especially on your unit exam. It's so easy to accidentally go left instead of right, and if you'll just double check it this way, you'll really save yourself a lot of time. Vertical stretch, compress, and reflection. So now we're going to look at vertical stretching. When the absolute value of A is greater than 1, it's a vertical stretch. The graph narrows. So here's an example of a graph looking like it's been narrowed. So we're going to take the top and the bottom and kind of stretch it, and it gets narrower. Vertical compress. When the absolute value of A is less than 1, it's a vertical compress, or you can call it a shrink. This is when your graph widens. So again, here's an example. We have a graph, and then this next one that I drew is wider. You can think of this as taking the top and the bottom and squishing it, so compressing it, which makes your graph wider. And finally, we have an x-axis reflection. If the output is multiplied by A, and the value of A is opposite or negative, the function, or of the original function, it is an x-axis reflection. So we've got a graph, and then if we reflect it down, that's an x-axis reflection. Graph the parent function and the transform function f of x equals 2x squared. Describe the transformation and identify the vertex. Okay, so starting with our parent function, we just graphed an example like this earlier. So recall, we're going to put our equation up here in the top, and then we need to find our h and our k for the vertex, which is still just 0 and 0. Go by 1s in your x-axis, plug those in. You're going to always get 1, 4, and 9 for your parent function. For our transformed function here, we're going to put the equation in the box. Our h and k are also 0. We have an a value of 2, but h and k we still don't have anything. So 0, 0 for our vertex. Plug in -1, -2, -3, 1, 2, 3 to get your y values. Okay, now we're ready to go graph. Again, we need to draw our x and our y axis. But this time I noticed that some of my y values for my transform functions are more than 10. I've got an 18 on there. Now sometimes we can move an axis and we can make it work to where all of our points fit on the graph, and sometimes we can't. But in this case we can, since we've got enough boxes on our graph to fit 18. So I'm going to take my x-axis and I'm going to move it all the way down to the bottom of the graph so that I can fit an 18 on my y-axis. So see right there, I've marked in red where that 18 would be. We're going to start by graphing our parent function. Again, we start with the vertex, we plot the points, and we draw our graph. For our transform function, start with your vertex, plot all the points, draw your graph. And we are going to note here that our transformation was a stretch by 2. So if we compare that purple function to the blue function, it's kind of like we took the vertex of the purple function and the top of it, where those arrows are, and we pulled them apart and we stretched it to make our graph narrower. In this next problem, we've got the same thing going on. We're going to graph our parent function and then the transformed function. Our parent function, we should be really good at filling out this table by now. To get our y values, we're going to do just like normal, plug them into the equation. And we're going to get -4.5, -2, and -0.5. Now, if you prefer the fraction form of these, then that's great. Put fractions in here. But if you'd rather look at the decimals, then that's great as well. The decimals that we have going on here are half, just 0.5. we are all really capable of finding that half mark on these boxes. So we're going to go ahead and graph all of these points. But if you have any decimals that are a little bit more hairier than that, maybe a repeating decimal, then it's okay if you only graph the points that have whole numbers. In this case, it would be these 3 points right here. But you do have to have at least 3 points. You can't just graph the vertex. So moving on to graphing, all of my coordinates are less than 10, so I can just put my x and y axis in the middle, and I'm going to go ahead and graph my parent function. Okay, now moving on to our transformed function. You can notice here that we've got some transformations going on. Either you can look at the equation and we see that there's a negative, or if we look at the graph, we see that the graph is now facing down. So we know that there's been a reflection. We also see in the graph that there's a 1/2 for our a value. That would be a compress since it's less than 1. And it's a little hard to see, but my blue graph is actually wider than my purple graph. So think about taking the purple graph, taking the top and the bottom and squishing it closer. It's going to be a wider graph in the end. Notice that I didn't write compress by -1/2. That negative means reflection and the 1/2 means a compress. So make sure that you separate those two in your mind. Okay, you've got 2 more problems left in this notes, and I want you to pause your video, try those 2, and then come back and check your answers with me.